All right, guys, welcome to 11.2 Sequences, Series, and Sigma Notes. A sequence is an ordered list of numbers. Each number in the list is called a term. There are finite sequences, which have a certain number of terms, and infinite, which goes on forever. So basically, we're looking at number patterns here, and hopefully this is something that you guys will enjoy. So for A, find the next four terms of the sequence. We're going from 3 to -1 to -5 to -9. What is the pattern here? You should be able to tell me what the difference is between each of these numbers. So the pattern in this sequence is to subtract 4. It's going down by 4 each time. Or you can look at that as adding -4. But we're just going to look at that as we're going to subtract 4 each time. What are the next four numbers, four terms of the sequence? Well, -9 minus 4 is -13, minus 4, -17, -21, and -25. All right. Hopefully that was an easy little start. So for the next one, we're going to find the first four terms of the sequence given by n is equal to n3 plus 1, n cubed plus 1, sorry. All right, so we're always going to start with 1 in this case, unless they've told us to start elsewhere. So we're going to start with 1. And then we just plug in 1 cubed plus 1, which is equal to 2. Then we have a2, which is equal to 2 cubed plus 1, which is 8 plus 1, which is 9. Then we have a3, which is equal to 3 cubed plus 1, which is 27 plus 1, which is 28. And then we have a4, which is equal to 4 cubed plus 1, which is equal to 65. All right, so our first four terms are 2, 9, 28, 65, and that's where it keeps going. All right, so example 2, a recursively defined sequence. All right, find the fourth term of the recursive sequence. A1 is equal to 3, and an is equal to 3an, n minus 1, minus n plus 2. So these are getting a little bit more intricate. But if they give you one number, a1, if a1 is equal to 3, find all this, you're going to have to use this. We're going to need this because this is a recursive sequence. That means it builds. And I'm going to show you how. So first off, over here in the corner, n minus 1 means prior term. So we already know that a1 is equal to 3. So we're going to jump straight to a2. We can't just jump to a4 because we don't know what a3 is. We would have to do 4 minus 1. We can't do a3 because we have to know what a2 is. And we need a1 to find a2. And you're going to keep using the prior answer to find the next one, and that's what makes it a recursive sequence. So we have a1, we need a2. a2 is 3 times a2 minus 1, which is a1, minus 2 plus 2. All right, so luckily, because it's 2, we can just cancel that out. So this is just, again, 3 times a1, 3 times 3, which is equal to 9. All right, so now I know that a2 is equal to 9. Okay, we know that a1 is equal to 3. Now to find a3, we're going to have to plug in a2. 3 times a3 minus 1 minus 3 plus 2. All right, so we have 3 times, and I can go ahead and plug in a2, which is 9, minus 3 plus 2. So we have 27 minus 3 plus 2, which gives us 26. So A3 is equal to 26. And we just have to do one more because all we're looking for is the fourth one. So A4 is equal to 3 times, and because we already know that an minus 1 is the prior term, I'm just going to go ahead and write 26. Minus 4 plus 2. All right, when you plug all that in, you'll get 76 as A4, and this is our final answer. All right, so recursive means that, again, you'll need the prior term to find the next one. You have to build term to term until you get to the one that you're looking for. Earlier this year, we examined end behavior of graphs. All right, recall if f of x is equal to 2x plus 3, the end behavior is what? Well, let's just kind of graph it. It's going to look something like this. The limit of f of x as x approaches negative infinity is negative infinity. And then the limit of f of x as x approaches infinity is infinity. So as long as we're going towards infinity, it keeps going up. And same for negative infinity. All right, and then e to the x, which is something like that. The limit of f of x as x approaches negative infinity is actually 0. It'll never cross the x-axis here. And then the limit of f of x as x approaches infinity. Uh-oh. Let me turn my lights back on. As x approaches infinity, is also going to be infinity because it's just going to keep going up. No asymptotes there. If a sequence has a limit such that the term approaches a unique number, then it is said to converge. If not, it is said to diverge. All right, and you're going to see that down here. So determine if each sequence is convergent or divergent. Hint, find the first 5 terms and then think about it. Okay, so let's start with this first one. We're just going to find the first 5 terms and go from there. So we have A1, which is equal to 20 times negative 1/2 to the first. Okay, that's just 20 times negative 1/2, which is going to be equal to negative 10. A2, 20 negative 1/2 squared, which gives us 1/4. 1/4 times 20 is going to be 5. All right, then we have A3, which is equal to 20 negative 1/2 cubed. When you plug that into the calculator, it's going to be negative 5/2. A4, 20 negative 1/2 to the 4th power. You're going to end up with a positive 5/4. And then a to the 5th, which is equal to 20 times negative 1/2 to the 5th power. It's going to give us negative 5/8. All right, so let's write this out. We've got negative 10, 5, negative 5/2, 5/4, negative 5/8. So the values oscillate, which means kind of like we're going, let's see, negative 10, positive 5, negative 2.5, 1 1/4, negative 5/8, and it's kind of looking like that. And this is an oscillation, by the way. Oscillate, but is heading to 0. that means it is convergent. All right, let's look at AN is equal to negative 5n plus 4. So we have A1 is equal to negative 5 times 1 plus 4. That means negative 5 plus 4, which is negative 1. A2, negative 5 times 2 plus 4. That's negative 10 plus 4, which is negative 6. A3 is equal to negative 5 times 3 plus 4, which is negative 15 plus 4, which is negative 11. Looks like we're just getting further and further away here. A4, negative 5 times 4 plus 4, negative 16. And then A5, negative 5 times 5 plus 4 is negative 21. All right. The values are headed to negative infinity. Which means it's a divergent. All right, I will do the next page on another video.